This lecture is going to look at how you find the sample size or the sample size needed to estimate the population proportion within a given margin of error. So here's how these problems are going to work. You're going to be given the margin of error. So the problem will be something like, oh, I want to find the sample size needed to be within 2% or 0.02 of the actual population proportion. And to do that, what you're going to do is then solve for the sample size. Okay, and that's that. The thing with this one is going to be a little different from the previous lecture. There's two formulas for this one, okay? Depending on if you're given a previous estimate for P, for the proportion. And when you see, I'll do an example of each of these formulas so you can see when they'll be used. Okay, so the sample size needed for a specified margin of error E, so that's the margin of error you're going to be given, and the level of confidence, 1 minus alpha. So it's going to say something like a 99% confidence level or 95. It's just this. N is equal to P hat times 1 minus P hat times the critical value. So again, Z of alpha divided by 2 is the critical value. And we're just going to look this up from the table. Okay, so from the given table, you'll see in the coming slides. And the formula uses p hash, which depends on n. Okay, so the quantity we're trying to determine. Okay, so this is our general formula for this. So there's two possible solutions to this, right? Because one is we don't know what p hat is for these problems because we haven't taken our sample. Okay, one is to use the estimate of p hat based on a pilot study or an earlier study. So in this type of problem here, you'll be given a previous value of p hat. And this will make more sense when you see the first example. Or the second thing you'll do is when you're not given a previous value of p hat, you're just going to let p hat be equal to 0.5. Okay, the reason we do this is it gives the largest possible value of n for any given level of confidence and any given margin of error. So it gives you the largest possible n. So in this case, you're just going to like oversample a little. Okay, this is just always better. Okay, so first one here, this is sample size needed for estimating the population proportion P. Okay, this is when you're given a prior estimate. So the sample size required of obtaining a 1 minus alpha times 100% confidence interval for P, where you're given some margin of error E, is just given by this. And you're always going to round up to the next integer. So it's N is equal to P hat times 1 minus P hat, and then in parentheses, the Z critical value divided by the margin of error squared. Okay, and this is where p hat here is a prior estimate, so will be given. So if p hat's not given, and I'll do an example of both, you're just going to use this. So if a prior estimate of p is unavailable, this is just the sample size. So where does this 0.25 come from? Well, it's p hat times 1 minus p hat. So you're just going to let it be equal to 0.5. So 0.5 times 0.5 is 0.25. So 0.25 times the critical value divided by E squared. Okay, so let's do an example of both of these. Okay, so a sociologist wanted to determine the percentage of residents of America that only speak English at home. Okay, so it's not a bilingual household. So what sample size would be obtained if she wishes to estimate to be within 3 percentage points? Okay, so that's the margin of error that the sociologist wants. Okay, got to change it to a decimal. With 90% confidence. So Z of alpha divided by 2 here comes from a 90% confidence interval. Assuming that she uses the 2000 estimate obtained from the Census 2000 supplementary survey So this is 82.4%. This is the previous estimate that's given. Okay, so you're given that p hat here is equal to 0.824. So now you can just see it's going to be just to plug in and follow the formula. All right, so the margin of error is equal to 0.03. They wanted a 90% confidence interval. So you're going to use the critical value 1.645. P hat is equal to 0.824. So you're just going to use this formula. N is equal to P hat times 1 minus P hat times the critical value over E squared. All right, so let me show you in a graphing calculator how they get this. Okay, so you're going to take P hat, which is 0.824, times, and then in parentheses, 1 minus 0.824, close the parentheses. Then times, we're going to start a new set of parentheses, the critical value, 1.645, divided by the margin of error, which you need to change to a decimal, close the parentheses, square it, you get 436.04. 436.04. Because there's a little bit of a decimal, you always round this up. So the sociologist must survey 437 randomly selected Americans for this. Okay, so this is just straight following the formula when you're given the previous estimate. All right, so let's do an example where you're not given the previous. Okay, so a certain statistics instructor wants to estimate the proportion of students that cheat on exams. Ooh. All right, so what sample size must be obtained in order to be 95% confident, okay, that the population proportion is within a margin of error of at most 0.02 from the estimate p hat. Okay, so you're given the margin of error. The z critical value then, right, is going to come from a 95% confidence interval, right, because 95, so 1.960. And then you're not given a prior estimate. Okay, it's nowhere listed in there. So then you're just going to use the formula 0.25 times z of alpha divided by 2 over e squared. So n is equal to 0.25, my critical value, which is 1.960. I want to be at most 0.02. And I need to square it. All right, so let's grab our calculator. So it's 0.25 times, and then in parentheses, 1.960 divided by 0.02. Close the parentheses, then we have to square it. And this you'd have to call 2,401 students for this, or a survey. So the stats instructor would need to sample 2,401 students. Okay, and this is so that the margin of error then would be that 0.02. All right, class, I hope to help seeing both of these examples, and you're ready to tackle some problems now.